Hello students, your physics teacher Hassan Darwish with you. In the last two videos about the angular momentum, I explained the concept and the definition of the angular momentum of a particle and of a system of particles, whether this system rigid or deformable. Now in this video, I'm going to explain the second objective. Here it is. State and apply the theorem of angular momentum. Let's start. This is the angular momentum of a particle, the general definition. We reduce this to this rule, sigma equal I theta prime, right? And the SI unit is kilogram meter squared per second, okay? We solved also direct example, and also I explained the angular momentum of a system of particles. Here the system is discrete system of particles. Sigma of the system is sigma 1 plus sigma 2 plus etc. for the whole particles. And in the case of rigid body, sigma equal I theta prime, but here I is the moment of inertia of this body, this system, not of a particle, so it has special rule. So every rigid body has a special value of I, and it is always given in the exams. Now let's start with the theorem of angular momentum. Say we have any system of particles, whether this system is rigid or deformable. I mean rigid system or discrete system of particles. And this system is subjected to many forces. Okay? So, because this system is subjected to many forces, so it possesses in general angular acceleration, and consequently possesses also angular momentum. So sum of moment is equal derivative of the angular momentum of this system with respect to time. This is the theorem of angular momentum. So sum of moment is equal derivative of the angular momentum. You can also say derivative d sigma by dt equal sigma prime, as in mathematics, for the whole system. Clear? Okay. Now, in the case of rigid system, like this body, which could be a disc, sphere, rod, etc. In the case of rigid system, you know sigma equal I theta prime, and I is constant. So this is a multiplicative constant. When you make derivative here, say you do like this. I theta prime, and here is what? Prime. Clear this prime. Because I is a constant, so we can get it out of the system, of the derivative I mean here. So this becomes I prime, and the prime we have double prime, so it becomes I theta double prime. Okay, so what is this? Do you remember? This means what? This is sum of moment equal I theta double prime. This is nothing more than Newton's second law in rotation. Don't forget this. Here it is. Let me write it like this. This is Newton's second law in rotation. Sum of moment equal I theta double prime. Okay, let's do an application on this rule, as we did in back one. In this example, we have this rigid system that consists of two blocks, A and B, and having the same mass, m equal 50 gram. The rods AB and CD, AB and CD have negligible mass. The system is initially rotating around CD with an angular speed theta prime equal 5 radian per second. So initially the system was in motion. It was rotating, means it has initial velocity, and in reality this represents the initial angular velocity, because at equal to 0 a motive couple of constant moment 0.08 Newton meter is applied on this system for 5 seconds. Okay? Now neglect friction and treat the blocks as particles. Determine the linear speed v of A and B at equal 5 seconds. Let's solve the example. Okay, first of all, you know that you want to find V of A or V of B. There is a relation between V and theta prime, right? V equal R theta prime. You remember this from last year, angular speed. But the radius here, this is the radius, because here is point O for the circle, right? This is a circle. Here is the center of the circle. So the radius is A. So this is equal A theta prime. But we don't have theta prime, right? Okay. So to find theta prime, we have to find the angular momentum, sigma. But also to find sigma, you have to apply what? The theorem of angular momentum. Sum of moment is equal d sigma over dt. But as I said before, d sigma over dt is nothing more than what? The derivative, sigma prime, right? Okay. Let's find the moment now. But to find the moment, we have to find the forces acting on the system. Here is my system, and here is O. Now A and B is what? Have the same mass. So this is, here is the center of mass. That's why I can say here the blocks, I prefer to write it like this in order not to catch a misconception. And here is delta, axis delta, which is C, okay? Axis of rotation. Now what are the forces acting? Weight of A and weight of B, right? The reaction of the axis R, and what? The moment here or here, doesn't matter. The moment M, the motive couple. But you know that the moment of R is 0 because it is along the axis, intersect the axis. And also the moment of the weight here, mg, is also 0 because it is parallel to the axis. So when the force is either intersecting the axis or parallel to it, you know that its moment is 0, right? Similarly here. So the moment of the three forces R, mg is 0. We are left only with this moment. So we have only here now M is equal sigma prime. antiderivative you get, because this is constant, you can make antiderivative for the constant and becomes moment time plus sigma initial 0 if you make the antiderivative, right? Everything is given. Now m is given here 0. I prefer to save time. Let me do this in order to save time. You know that sigma is what? I theta prime. Why did I do this? Because I want what? Theta prime. Remember, I want theta prime. So I theta prime is equal moment, which is 0.08, and also time is given, plus what? I theta prime 0. Now let's divide by I. You get theta prime equal moment over I time plus, you see it's simpler, theta prime initial. Theta prime initial is given 5, and this is 0.08, this is 5, etc. So at t equal 5 seconds, we get what? Sigma equal 0.08 times 5 over I plus 5. We are given this 5. Here it is. Okay? Initial. And moment is also given. The time is 5. So you get 0.08 times 5 is what? 0.4 over I, which is the moment of inertia of this system, plus 5. But now this system consists of only 2 particles. It acts as a rigid system, right? But this rigid system consists of 2 particles only. And you know that I for particles is equal I1 plus I2, or M1 R1 squared plus M2 R2 squared. And in reality this is equal the same mass and the same radius to MA squared. So if you do the calculation and try to get V. Okay, I think V becomes 10.5 meter per second. Okay, so this is everything in this video. In the next video I will solve another example on the theorem of angular momentum. Take care. Bye bye.